Algebra Unit 11, Lesson 4, Notes 4, Sequences and Explicit Formulas. A sequence is a set of numbers, called the terms of the sequence, in a specific order. An arithmetic sequence is a numerical pattern that increases or decreases at a constant rate or value, called the common difference, or D. A geometric sequence is a sequence in which each term after the first is found by multiplying the previous term by a constant r, called the common ratio. Determine whether the following sequences are arithmetic or geometric, then determine the common difference or ratio. Finally, record the next three terms. Okay, let's jump to letter C. 256 to 128 to 64 to 32. It's decreasing. It's not being subtracted because of the jumps are so high. For me, 64 to 32, I know that's dividing by 2, so you can do a quick check in your calculator. 256 divided by 2 does give you 128, and divide by 2 again, it does give you 64, 32, etc. However, so I know this is a geometric sequence. However, I can't divide in geometric sequences. I have to multiply. So because it's divide by 2, my ratio is going to be 1/2, because divide by 2 is the same as multiply by 1/2. Now it wants the next three terms. So continue. 32 divided by 2 is 16. Divide by 2 is 8. Divide by 2 is 4. Let's look at letter D. In letter D, we have some fractions here, and we have some different denominators as we go through it. We have 7/8 to 3/4, to 5/8 to 1/2, to 3/8. I'm looking and I'm noticing that every other term is decreasing by 2/8. So let's say I were decreasing by 1/8. This will be 6/8. Then this one will be 4/8. 7/8, 6/8, 5/8, 4/8, 3/8. But what's happening is it's reducing. 6/8 reduced is 3/4, and 4/8 reduced is 1/2. So this is an arithmetic sequence because I'm subtracting, and the common difference is negative 1/8 because I'm subtracting 1/8. So if I continue subtracting 1/8, I would get 2/8, which reduces to 1/4. Minus an eighth gives me 1/8. Minus an eighth gives me 0. Let's do one more. Let's look at E. Here we've got negative, positive, negative, positive, negative. Okay, so that right there tells me that it can't be an arithmetic sequence. It's going to have to be geometric, and it's going to be multiplied by a negative number. So negative 1 to 2, I can multiply by negative 2. Let's continue, see if that works. Times negative 2 gives me negative 4. Times negative 2 gives me 8. Times negative 2 gives me negative 16. So this is geometric with the common ratio as negative 2. So if I continue the pattern, negative 16 times negative 2 is positive 32, then negative 64, then positive 128. A sequence can be generically viewed as a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, ... a sub n, where the subscripts or labels represent the term number. For example, the first term is a sub 1, the second term a sub 2, the nth term is a sub n, and that would be an unknown term. Sequences can be defined by a classic function formula, where each term can be expressed in terms of the first term a sub 1. So we have what are called explicit formulas, and I have those key concepts there for reference, but our explicit formulas are on the bottom. Here's the arithmetic, here's the geometric. A sub 1 is your first term, D is your common difference, N is your unknown, and in geometric, again, A sub 1 is the first term, R is your common ratio, and N is your variable. Both of these formulas are given to you on your reference sheet on the exam. So you don't have to memorize them, but you need to know what they mean. Letter A. Given the sequence negative 12, negative 8, negative 4, 0, write the explicit formula for finding the nth term. What we need to figure out first is whether it's geometric or arithmetic. So find the pattern. From negative 12 to negative 8 to negative 4 to 0, we're adding 4. So I know this is an arithmetic sequence where the common difference is positive 4. So using your formula on the front of the sheet, we have a sub n equals a sub 1 plus the quantity n minus 1 times d. A sub n we're leaving, that's the nth term. Our first term is negative 12 plus, leave the n minus 1, and your common difference, which we figured out, is 4. From here, you're just going to simplify it. So negative 12, distribute that 4, so 4n minus 4. Combine your like terms. A sub n equals negative 16 plus 4n. So if you wanted to find the 50th term, you can use this formula rather than listing out the previous 49 terms. Letter B, given the sequence 3, 1, 1/3, 1/9, 1/27, write the explicit formula. Then find the value of the 7th term. So not only are we finding the formula, we are also finding the 7th term. Again, I can just continue the pattern, but I'll show you how to use your formula to find that term. All right, so I have 3 to 1 to 1/3. I'm definitely not adding or subtracting, but I am dividing. Remember, we can't use division. So I know this is geometric, and the common ratio, if I'm dividing by 3, I'm really multiplying by 1/3. Okay, the formula for geometric is a sub n equals a sub 1 times r to the n minus 1. So a sub n equals, my first term is 3, r is 1/3, and I'm raising it to the n minus 1. That is the formula. There's nothing that you can simplify. You cannot do 3 times 1/3 because 1/3 has an exponent. So you have to leave it as is. Now to find the 7th term, all I'm going to do is plug in 7 for n. So the 7th term, a sub 7, equals 3 times 1/3 to the 7 minus 1. Let's clean it up a bit so I can put it in my calculator neatly. 7 minus 1 is 6. Go ahead and plug 3 times 1/3 to the 6 in your calculator. Then hit math, frac, enter. Let's leave it as a fraction since our terms in our sequence are fractions. And it's 1/243 is your 7th term. Letter C. In the following sequence, negative 4/5, 8/5, negative 16/5, 32/5, which term has a value of negative 256/5? Well, I have negative, positive, so I know it's a geometric sequence. The common ratio looks like I'm multiplying by negative 2. Now, I don't actually have to write a formula. It doesn't ask me to. I want to know which term gives me negative 256/5. I'm simply just going to continue this pattern. So let's bring down my 32/5, which was my 4th term. Let's multiply by negative 2. This would be negative 64/5, which is our 5th term, times negative 2 is 128/5, which is our 6th term, times negative 2 is negative 256/5, which is our 7th term. So our 7th term gave us that value. Letter E. The 4th term of an arithmetic sequence is 80, and the first term is 98. Find the common difference. So I have 4 terms. I know the 4th is 80, and the first is 98. I also know it's an arithmetic sequence, so I know I either have to add or subtract. Well, looking from my first term to my last term, it definitely decreases. So I know the common difference is negative. Okay, I'm subtracting something. So what I can do to figure this out, you can do guess and check if you want. I'm just going to do a couple calculations. 98 minus 80 is 18. To get to 80 would be 3 jumps. So 18 divided by 3 equals 6. So I'm going to say that my common difference is minus 6. Let's check that. 98 minus 6 is 92. Minus 6 is 86. Minus 6 is 80. So that works. Okay, let's look at letter G. Write the explicit formula, then determine which term has a value of 5. Okay, so this one we have to write the formula. We need to determine if it's arithmetic or geometric. Looks like I'm increasing, I take that back. I'm increasing, looks like by 0.25. So I'm going to say this is arithmetic, and the common difference is positive 0.25. The explicit formula is a sub n equals a sub 1 plus the quantity n minus 1 times d. A sub n equals negative 0.75 plus n minus 1 times 5. A sub n equals, let's clean it up a bit. Distribute that 5. Oh, not 5. Our common difference is 0.25. I was looking at the wrong place. Let's fix that. So 0.25n minus 0.25. Combine like terms, we get negative 1 plus 0.25n. So that's our explicit formula. When you have an arithmetic sequence, you can actually plug in your the 5 when you want to know which term has a value of 5. You can actually plug that in for a sub n. We couldn't do that on one of the previous examples because it was a geometric sequence, and we don't know how to solve an equation when we have a variable in the exponent. Okay, but we don't have any variables in the exponent, so we could actually just set up an equation to solve. So 5 equals negative 1 plus 0.25n. Add 1. 6 equals 0.25n. Divide by 0.25. And we get 24 equals n. So this would be the 24th term. I could have sat there and I could have listed all those terms like I did in that previous example. I believe it was letter C on a previous page. However, that would have taken a while. There are 24 terms. So when you have an arithmetic sequence, again, you can just plug that in for the a sub n. It's kind of like the total, if you were thinking of it that way. Okay, I believe you can actually do the rest of these on your own. The word problems aren't too difficult. Just use your formulas to help you figure them out.